Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and so today we are going to discuss one another topic from chemistry. This one is from physical chemistry. It belongs to the chapter Solutions and Colligative Properties. Let me write down the title first of all, Solutions and Colligative Properties. Solution and colligative properties. Okay, so this is the title of the chapter, and the title of the topic is expressing the concentration of solution. Expressing the concentration of solution. Okay, so this is the topic for today's discussion. So as far as solutions are concerned, in solution there are different types of the solution based on number of particles present in it. So that I am going to explain to you first of all. So the type of the solution and number of components. Okay, yes, so first type first type is a binary solution. Bi stands for 2. So in binary solution there are two components. Okay, so in two components it is one solute plus one solvent. Solute is nothing but the component which is present in smaller extent. Solvent is present in the larger extent. Second type of the solution is the ternary solution. In ternary solution there are three components. So it can be one solute plus two solvents, or it can be two solute plus one solvent. Okay, so this is a ternary solution. And the last type is the quaternary solution. So here the number of components are 4. So here it can be one solute plus 3 solvent, or it can be two solute, two solvents, or it can be three solute, one solvent, right? Okay, so these are the different types of the solutions on the basis of number of particles present in them. Okay, now here we are going to discuss about the one type only, and that is nothing but the binary solution. In binary solution there are two components, one is the solute, another is the solvent, right? We are going to talk about the binary solutions. Two components, one solute and another solvent, right? Binary solution. Now in these binary solutions, if I ask you, that is how you can find out the number of particles present in the solution, right? In that case, by observing just a solution, just take an example of the solution of sugar in water. Okay, if I take a glass of water, then if I add one teaspoon of sugar to it, if I stir it, the sugar is completely dissolved in the water. And then if I ask you to find out what is the number of particles present in it, so it's not possible for you by just observing it, right? Therefore different methods are there for finding out this number of particles. This number of particles is nothing but the concentration of the solution, right? So concentration means what? Concentration is nothing but how many solute or how many solvent particles are present in the solution. Okay, so that is nothing but a concentration. So concentration of solution can be expressed by two different ways. Okay, yes, so first way is called as qualitative method. Okay, in qualitative method, yes, and second way is the quantitative method, qualitative and quantitative method. In qualitative method, we are going to talk only about the quality, right? We are going to talk only about the quality. What do I mean by that? Like, we will, if you have, you might have seen the bottles of the solutions of acids and bases in your lab. You can some bottles have the dilute, some bottles have concentrated written on it, right? So what is the meaning of dilute and concentrated? In case of dilute solutions, the less amount of solute is present, less amount of solute is present, whereas in case of concentrated, more amount of solute is present, right? In case of concentrated, more amount of solute is present, right? So from dilute and concentrated, you can only talk about the quality, that is whether less or more, but you cannot actually tell how many exact, what is the exact number of particles present in dilute or concentrated. Therefore, in case of qualitative, we are only going to talk about the quality, that is only whether dilute or concentrated. Whereas in case of quantitative analysis, you are actually going to talk about, or you are actually going to calculate the number of particles present in the solution, that is quantity you are going to express. So we are going to discuss the quantitative methods in detail further, quantitative methods. Okay, yes, one by one I will write down those methods. There are different methods available here. So first of all, first method is by mass percentage. Mass percentage. Second method is volume percentage. Second method is volume percentage. Third method is mass by volume percentage. Fourth method is parts per million. Parts per million, also denoted as ppm. Parts per million. Then after parts per million, the next one is molarity, mole fraction. Mole fraction. After mole fraction, the next one is molarity. Yes, then after molarity, next is molality. There is just a difference of one letter here, R and L, molality. Next is normality, and the last one is formality. Last one is formality. So these are the different types of the concentration terms used for expressing the concentration of a solution. These are the quantitative ways of expressing the concentration, out of which in today's session we are going to discuss about the molarity. Yes, we are going to discuss about the molarity in detail. Okay, before starting that, let us just take a screenshot of this page. Okay, yes, now let us see in detail about the molarity. Molarity is denoted by the symbol capital M. Okay, so what is this molarity? Let me just write down. So this molarity is number of moles. Molarity is number of moles of solute. Number of moles of solute per liter of solution. Per liter of solution. So this is the molarity. So the molarity capital M has the formula. In the numerator it is number of moles. In the numerator it is number of moles divided by volume of the solution. Volume of solution, whole solution. Volume of solution in liter. So that is nothing but the molarity, right? As we know, the number of moles has the unit mole, and volume of the solution has the unit L. Therefore, units of molarity are mole per liter, or as we know, liter can also be written as dm3. So it is mole per dm3. Okay, or it can also be expressed, like this: mole per liter, or it can be also expressed like mole per dm3. Okay, so these are nothing but the units of the molarity. Now many of the time you might have observed, when we perform any experiment in laboratory, we perform it on small scale, right? We perform it on like 10 ml, 50 ml, 100 ml, 200 ml, 500 ml, but we do not perform it in terms of 10 liter, 5 liter, in terms of liters. Small scale experiment we perform. So if therefore many of the time in questions also, volume of the solution is given in milliliter, ml. So when it is given in milliliter, we have to modify the formula, right? Okay, so as we know, the liter, milliliter we have to convert to liter, right? We know that, as we know, 1 milliliter of solution is equal to 1 divided by 1000 liters, right? 1 milliliter is equal to 1 divided by 1000 milliliters. So that conversion factor we have to add in the formula. Okay, therefore what will be the new formula? Therefore molarity will be equal to number of moles of solution. There it is denoted by the symbol small n. Okay, and volume denoted by V. Okay, yes, same I will use for that. So molarity is equal to number of moles of solute divided by volume of the solution. If it is given in milliliter, then milliliter conversion to liter by multiplying it by 1 divided by 1000, or this 1000 I can take in the numerator. So it will be equal to number of moles of solute divided by volume in milliliter multiplied by 1000. Okay, so whenever the volume is given in milliliter, you are simply going to keep all the things as it is, just simply multiply the formula by 1000. Simply you are going to do this thing, multiply the formula by 1000. That's it. So these are the formulas of molarity. Now one more formula here I will write down, that is here number of moles. Okay, number of moles. What is number of moles? Denoted by symbol small n. In the first chapter of class 11 we have seen all these formulas. I am just writing again for revision purpose. Number of moles is equal to given weight divided by molecular weight. Okay, number of moles of a molecule is equal to given weight divided by molecular weight. Both of them should be in the same unit, gram, for an example. So these are the formulas which you need to know for understanding the molarity. Okay, just take a screenshot of this page and on the basis of this formula, let us solve one question. Okay, let us see question. Calculate the molarity. Calculate the molarity of a solution containing 5 gram of NaOH, 5 gram of NaOH in 450 ml of solution. 450 ml of solution. Here each and every word is important. Okay, you have to observe whether it is given solution or solvent. Accordingly you have to do the calculation part. Okay, yes, so let us see how to solve this question. It's very easy. So what is given? So we have to find out the molarity of the solution, right? Capital M of solution in which 5 gram NaOH is present, sodium hydroxide, in total volume of the solution, okay, is equal to 450 ml. So denominator is fixed, 450 ml, that is not going to change. What is going to change? Numerator we have to find, that is not given, right? Okay, what is the formula for number of moles? As we know, number of moles is equal to GW, that is given weight divided by molecular weight. Given weight 5 gram, molecular weight of NaOH we don't know, we can find out. Okay, yes, so let us see, let us find out, let us calculate molecular weight of NaOH, right? Molecular weight of NaOH, sodium hydroxide. Okay, as we know, atomic weights of sodium is 23, oxygen is 16, and hydrogen is equal to 1 atomic units. Okay, now therefore we can find out, therefore molecular weight of NaOH will be equal to 1 sodium, so 1 into 23, 1 oxygen, so 1 into 16, 1 hydrogen, therefore 1 into 1. Okay, so it is equal to 23 plus 16 plus 1. Okay, 23 plus 16 plus 1 is nothing but 40, right? So what is the molecular weight of sodium hydroxide? Molecular weight of sodium hydroxide is equal to 40 gram. Okay, therefore we have molecular weight, we can find out the number of moles. Therefore number of moles will be equal to given weight divided by molecular weight. Given weight is 5, molecular weight is 40, right? So it is equal to 1 divided by 8, that is nothing but 0.125 moles, right? What is the number of mole? Is equal to 0.125 mole of NaOH. Okay, yes, number of moles is known, volume is known. Now we can find out the molarity, right? We know the formula for molarity as molarity equal to capital M is equal to number of moles of solute divided by volume of the solution in liter. If it is not given in liter, then use the another formula. If you can see in this question, the volume is given in milliliter, so I use the formula for milliliter, volume in milliliter, therefore I will multiply the formula by 1000. Okay, so number of moles is 0.125, volume in ml is 450 multiplied by 1000. Okay, so it will be equal to 0.278 m. Okay, or it can also be called as 0.278 mole per liter, or it can also be called as 0.278 mole per dm cube. Okay, yes, so this is how we have find out the molarity of the solution by using the given formula. Okay, yes, take a screenshot of this page first of all. Okay, now let us see one more different type of question on the molarity. Second question. I'll write down the question first of all. Two solutions of a same substance. Two solutions of a same substance are mixed in following manner. Mixed in the following manner. Full stop. Okay, so 480 ml of 1.5 m. Capital M stands for its molarity is 1.5. 480 ml of 1.5 molar first solution plus 520 ml of 1.2 molar second solution. Full stop. What is the molarity of final solution? Okay, what is the molarity of final solution? Okay, yes, so first of all, for final solution, the volume of the solution will be addition of the volumes of the two solutions, right? First of all, we are going to calculate the volumes. Okay, let us see. So what will be the final volume, or which can also be called as total volume? Yes, what is the final volume is equal to V1 plus V2. V1 is the first solution, V2 is the another solution. So first solution is 480 plus another solution is 520. Okay, so 480 plus 520 will be equal to 1000, right? 480 plus 5000, 520 will be equal to 1000 ml, right? 1000 ml it will be. Okay, so 1000 is the volume of the solution, total volume. 1000 is the denominator. Now let us find out the numerator. Numerator is, in case of molarity formula, numerator is number of moles. Now I am going to tell you one more trick to find out the number of moles from the given information. What is the given information? For first solution, its volume and molarity, right? And for the second solution also, its volume and molarity, right? So how to find out the number of moles? By using the volume and molarity, I am going to tell you. Okay, yes, let us see how to for the first solution. Okay, for first solution, let us find out the number of moles. Okay, yes, so as we know, what is the formula for molarity? As we know, molarity is equal to number of moles divided by volume. Okay, volume of the solution, if it is given in liter, right? Okay, but here volume of the solution is given in milliliter, so I will multiply it by 1000, right? Yes, now this formula I can rearrange for number of moles. Okay, so number of moles will be equal to molarity into volume given in milliliter divided by 1000. Do you understand? So the same formula I can rearrange for finding out the number of moles. Okay, so what is the molarity of first solution? First solution molarity is 1.5. What is the volume in milliliter for first solution? 480, right, divided by 1000, right. So this is the formula of number of moles. N1 I will call, N1 is the number of moles of first solution, right. Okay, so this is M1. M1 stands for the molarity of first solution, V1 stands for volume of first solution. I can solve it then. So it will be equal to 480 multiplied by 1.5 equals to divided by 1000. Okay, that is equal to 0.72. Okay, what is the number of moles of first solution? 0.72. Similarly, I can find out for the second solution. Now for second solution, for that purpose also I can use the same formula. Now I will not derive it again. N2 is equal to M2 into V2 given in milliliter divided by 1000, right. So it is equal to M2. What is the molarity of second solution? 1.2. Volume of second solution 520 divided by 1000, right. So it will be equal to just a minute. Yes, so 1.2 multiplied by 520 divided by 1000, it is equal to 0.624 moles, right. This is the molarity of the second solution. Now I can find out the total moles. Total mole will be sum of the two, therefore total number of moles, it will be equal to N1 plus N2, right. N1 is equal to 0.72, N2 is equal to 0.624, and it is equal to plus 0.72, it is equal to 1.344 moles, right. These are the final moles. Okay, yes, now I can use the final volume and final moles for the formula. Therefore molarity will be equal to, okay, the final molarity, okay, molarity will be equal to the total moles, molarity will be equal to total moles divided by total volume, okay, divided by total volume multiplied by 1000, because total volume is also in terms of the milliliter. Total moles is 1.344, total volume is 1000 and multiplied by 1000, okay, multiplied by 1000. So 1000 gets cancelled, therefore final molarity will be equal to 1.344 mole per liter. Okay, yes, so this is the final answer, 1.344 moles per liter. Okay, do you understand? So this is how we can use this same concept of molarity for different types of the questions. Take a screenshot of this page. I hope you understood this question as well. Okay, so that's all for today. So today we have discussed the different concentration terms, and in which we have seen molarity in detail. So other concentration terms we will discuss some another day. So that's all for today. So before ending the class, let me just show you the DPP, that is daily practice problem. I hope you are able to see the portal. This is a teacher's portal. Go to the resources, then to the writing material, and then you can see the DPP. You can open it or download it. You write down the solutions on the paper or your notebook. Take a photograph of it, and you have to upload that photograph on your portal, so that teacher will evaluate it and let you know the suggestions and correction wherever required. That's all about DPP. So we are going to discuss the next topic in the next session. Thank you so much, students, for your precious time, and all the best to you.